Imagine a traveler, a silent wanderer journeying through the immense dark ocean between the stars. This isn't a being of flesh and blood, but a relic from a distant, unknown solar system, a chunk of ice and rock cast into the interstellar void eons ago. We call this visitor 3I Atlas. The I stands for interstellar, marking it as a rare guest from beyond our solar system. It was first spotted by the Atlas telescope network, which scans the night sky for moving objects. At first, it was just another faint smudge of light. But astronomers soon realized its path was a hyperbola, an open-ended trajectory, not bound to our sun. 3I Atlas was moving too fast to be captured by our sun's gravity. It was just passing through, a fleeting emissary from another star. For astronomers, discovering an interstellar object is like finding a message in a bottle from an unknown world. Each one carries the chemical fingerprints of its home system, a place so distant, its light may take millennia to reach us. 3I Atlas wasn't just a rock, it was a priceless artifact, a tangible piece of another corner of the Milky Way, delivered to our doorstep. Observatories worldwide turned their gaze to this traveler, analyzing its color, brightness, and the ghostly coma of gas and dust that revealed it was behaving like a comet. We had a rare, limited-time chance to study a piece of alien geology up close before it vanished back into the interstellar darkness. Every object in our solar system, from Jupiter to the tiniest asteroid, follows a path dictated by gravity. The Sun, as the most massive object, orchestrates this cosmic dance. We can predict the orbits of planets and comets with astonishing precision. This predictability is a triumph of science. 3I Atlas, though interstellar, was expected to follow the same rules. Its hyperbolic path shaped by its speed, direction, and the Sun's pull. Astronomers plotted its course confidently, expecting it to swing around the Sun and then head back into the void. This predictability is the foundation of modern astronomy, allowing us to send probes, anticipate meteor showers, and protect our planet. The world's telescopes were trained on 3I Atlas, ready to capture every moment of its journey. We had a schedule, when it would be brightest, when it would pass Mars, when it would depart. The scientific community was united, expecting to fill in the details of a story whose ending seemed certain, or so we thought. The universe, as always, had a surprise in store. Then, something unexpected happened. An observatory in Chile noticed 3I Atlas wasn't quite where it should be, a tiny deviation, easily dismissed as error. But soon, observatories in Hawaii and elsewhere confirmed it. The deviation was real and growing. 3I Atlas was drifting off its predicted course, as if nudged by an unseen hand. The change was subtle at first, but persistent. The object was accelerating in a way gravity alone couldn't explain. In the precise world of orbital mechanics, an unexplained change is monumental, like a ball changing direction mid-air with no wind. For 3I Atlas, deep in space, there is no wind. The force had to come from the object itself, or something else. The story we thought we knew was being rewritten in real time. News spread rapidly through the astronomical community. Telescopes were retasked, and scientists scrambled to understand the anomaly. The predictable visitor had become an enigma. The simple equation now had an unknown variable. 3I Atlas was no longer just a messenger from another star. It was now one of the most compelling astronomical mysteries of our time. Every new observation only deepened the puzzle. The world watched as the cosmic clockwork slipped out of sync. The mystery had just begun. The most baffling part? We don't know why 3I Atlas changed course. We've aimed our most powerful instruments at it, across the electromagnetic spectrum, and found nothing unusual. No impact, no eruption, no visible event. The object looks unchanged, just in the wrong place. This is the essence of a true scientific mystery, plenty of data, but no explanation. Physics tells us a change in motion requires a force. We see the acceleration, we know the mass, but we can't find the force. It's a phantom push, a violation of our expectations. The emptiness of space makes a random collision unlikely, and we'd expect to see debris if it happened, but there was nothing, no flash, no cloud, just silence. 3I Atlas sails on, serene and silent, ignoring the cosmic rulebook. This is what makes science thrilling, confronting the unknown. Every astronomer and physicist is now asking the same question: what is going on? The silence of 3I Atlas is a challenge. A dare to our intellect and imagination. The ghost in the machine beckons, and we are compelled to follow. The hunt for answers is on. Faced with a mystery, scientists propose hypotheses. The leading idea, outgassing. As 3I Atlas nears the sun, it releases gas and dust like a cosmic sneeze, nudging itself off course. This is common in comets, but here's the catch. The outgassing from 3I Atlas appears uniform and gentle. To cause the observed acceleration, a powerful sustained jet would be needed, something we should see as a bright, fan-shaped feature. But we see no such jet. Could it be an invisible gas? Maybe, but that would require new, unobserved chemistry. The common ices in comets, water, carbon dioxide, carbon monoxide, all produce visible signatures. Proposing an invisible jet is a big leap, creating more questions than answers. So, while outgassing is the top contender, it doesn't quite fit the facts. The force seems too strong, its source too well hidden. Scientists are modeling complex scenarios, jets that turn on and off, or are hidden by the object's rotation. For now, the cosmic sneeze remains an imperfect explanation. The mystery persists. If 3I Atlas isn't pushing itself, maybe something else did. One idea. A collision with a smaller, unseen object, a space rock imparting enough momentum to alter its path. Our solar system is full of debris, and a collision would provide the needed force. But there's no evidence, no flash, no debris, no sudden change, just a gradual deviation. Could it have been something exotic, like dark matter? Unlikely. Dark matter interacts only through gravity, not by pushing. Another possibility. 3I Atlas broke apart, and a fragment flew off, altering its path. We've seen comets disintegrate before, but we'd expect to see fragments. Telescopes, including Hubble, have searched for companions, but 3I Atlas appears alone. The invisible push remains unexplained. The mystery deepens, and the search for answers continues. The cosmos keeps its secrets well. The global scientific community has mobilized to solve this puzzle. Every major telescope is observing 3I Atlas, searching for chemical signatures or hidden jets. Radar systems are mapping its shape and rotation, hoping to spot a plume invisible to optical telescopes. Astronomers are reanalyzing all previous data, hunting for subtle clues missed before. This forensic astronomy requires patience and powerful computers to sift through mountains of information. The excitement is palpable. Scientists are debating, collaborating, and even sketching out plans for a high-speed probe to intercept 3I Atlas. The allure of solving such a fundamental mystery is a powerful motivator. When faced with the unknown, humanity rolls up its sleeves and gets to work. The strange journey of 3I Atlas is more than a puzzle. It's a reminder of our place in the universe. We live on a tiny world, orbiting an average star, in a vast galaxy. Interstellar visitors like 3I Atlas are physical links to that wider cosmos, pieces of other worlds, delivered by chance. Each encounter expands our cosmic consciousness, reminding us our solar system is part of a vast, interconnected galactic ecosystem. The story of 3I Atlas is about the dynamic, ever-changing nature of the galaxy itself. Astronomy's greatest gift is this sense of wonder and humility. To study an object like 3I Atlas is to look upon a true alien, a thing born of another sun. The universe is a library of countless volumes, and we've only just begun to read. What happens next in the saga of 3I Atlas? We don't know. The story is still unfolding, and we're privileged to witness it. Will we find the hidden jet, a companion fragment, or will the mystery endure? Whatever the outcome, 3I Atlas has already sparked curiosity, collaboration, and innovation. Its greatest value may be the questions it inspires, pushing us to build better telescopes and dream bigger. As it returns to the darkness between the stars, we'll keep watching, hungry for the final clue. The quest to understand is the greatest adventure of all.